Now let's apply the binomial theorem and the pattern that we saw in Pascal's triangle and with the exponents to something other than just a plus b. So let's expand 2x minus 3 to the fourth. When we say expand, we mean expand it into all of its terms. So the first thing we're going to do is just multiply it out by hand to see what we would get doing it that way. So obviously we're multiplying out 4 factors of 2x minus 3. You need to do it in pairs, and since they're the same, once you've done one, you've done both. So notice this would be 4x squared minus 6x minus another 6x, giving us negative 12x for the middle term, and then negative 3 times negative 3 is positive 9. So now I'm going to have two trinomials multiplied times each other. And what I'm going to do is first take the 4x squared times each term in the second trinomial. So 4x squared times 4x squared, 4x squared times negative 12x, 4x squared times 9. And these are the three terms I get. Then I'm going to do the same thing with negative 12x and with 9. And this is the polynomial I get. So take a minute if this is something that you need a little practice with to make sure you get the same thing I do. If not, then you can move on. So this is what we would get multiplying it out by hand. Now, how would we do the same thing using the pattern that we see in Pascal's triangle? So let's take a look at what we know so far. If we have something to the fourth power, that would correspond to the row in Pascal's triangle where the second number is 4. Remember, this is a plus b to the 0 is 1, a plus b to the first, a plus b squared, a squared plus 2ab plus b squared, and so forth. So when you see this n, this coefficient that you're raising the binomial to, it is the second number in the row of coefficients. Then my a, instead of just being a, is 2x, and my b is negative 3. So I'm looking at the pattern a plus b to the fourth. So this is the pattern you get with Pascal's triangle. A to the fourth plus 4, a to the third b, plus 6, a squared b squared, plus 4ab cubed, plus b to the fourth. So always start out by just writing out the pattern. You can use that as a template then. Every place there's an a, then you're going to substitute 2x, and every place there's a b, you're going to substitute negative 3. It's very important to put the 2x and the negative 3 in parentheses. If you don't, you are very likely to make careless mistakes as you go on to the next step. So notice what I've done here, substituting the 2x in for a and the negative 3 in for b with the coefficient still in the front. Now, notice also I've underlined these to show that each of these is a separate term. All of this turns out to be one term. All of this is second term. All of this is the third term. It's very easy for students to get careless with their notation and write 4 times 2x cubed times negative 3, but not put the parentheses on, and it turned it into minus 3 here instead of times negative 3, and then end up with an extra term and wonder where it came from. So just be careful with your notation. Okay, so now remember that this whole thing is 2x times itself 4 times. 2x times 2x times 2x times 2x. So it's going to be 2 to the fourth and x to the fourth, not just 2x to the fourth. That's another reason to put the parentheses, to be careful about that. 4 times 2 to the third x to the third, and then times negative 3. 6 times 2 squared x squared times negative 3 squared, which I just wrote as positive 9. 4 times 2x times negative 3 to the third, negative 27, and negative 3 to the fourth is 81. Now I just need to simplify each of these terms, putting the coefficient in the front. Okay, so 2 to the fourth, x to the fourth, 16x to the fourth. This is 4 times 2 to the third, which is 8, times negative 3, which is negative 96, x cubed. 6 times 2 squared times 9, 216. 4 times 2 times negative 27, negative 216, and then 81. Notice that when the second term is negative here, so we have 2x minus 3, that you're going to always end up with alternating signs on your polynomial. So positive, negative, positive, negative. So make sure that you're careful about that as well. Okay, so that's using the pattern from Pascal's triangle and the pattern of exponents that we observed. All right, now what about using the binomial theorem then to do the same thing? So I have put the binomial theorem down here again, and we're going to put the numbers into it that go specifically with this situation. So a plus b to the n becomes 2x minus 3 to the fourth. So a is 2x, b is negative 3, and n is 4. So in my binomial formula, using sigma notation, it's r equals 0 to 4. 4 select r, 2x to the 4 minus r, and negative 3 to the r. And then I am going to go from r equals 0 to r equals 4, substituting those into the formula and finding the 5 terms. So that's what I've done. I'm just going to go ahead and open this up now. So here's term number 1. Notice I wrote term number 1 is r equals 0. It's not r equals 1, so be careful about that. Term number 2 is r equals 1. So I put 0 in every place there was an r, and I have 4 select 0, which is 1, 2x to the fourth, 4 minus 0, so 2x to the fourth, x to the fourth, and negative 3 to the 0 is 1, so there's 16x to the fourth. Not a surprise, we've done this twice already. We know what the answer is supposed to be. Let's just look how it appears, though, in the formula. 4 select 1 is 4, 2x to the third, 2 to the third, x to the third, negative 3 to the first. There's our second term. Third term, okay, 4 select 2. Once again, we've done this already. But remember, that would be 4 factorial over 2 factorial, 2 factorial, and that's where the 6 comes from. So we've done this enough times that I just wrote 6 here, but we're going to do another example on the next video where we have something we haven't done, and I show a little more detail about how to get that coefficient with the formula for the binomial coefficient. Okay, so 2x squared, and then times 9, negative 3 squared. Once again, be very careful with your parentheses that when you have a negative number to an even exponent, it should turn out to be a positive number. So there's our term number 4 and term number 5. Okay, so I got kind of go down a little bit to show that. Get the rest of that. Okay, sorry. So there are the last 3 terms. Okay, so this is how we apply the binomial theorem and the patterns we observed in Pascal's triangle to multiplying out any binomial. The next video will show a couple of examples then that aren't to the 4th power, so you can see some different applications.